Good afternoon, students. Now we are see about recovery system. Recovery system. Recovery system. We are see about 5 topics: failure classification, storage structure, recovery and atomicity, log based, and remote backup. First, see about failure classification. In failure classification, there are 2 types of errors. Transaction, first one is transaction failure. In transaction, logical errors and system errors are occurred. Logical error means what? If the transaction cannot complete due to some internal errors, that is called logical errors. In system error means the system must terminate an active transaction due to an error condition. This is called system errors. Then system crash. System crash is due to power failure. Next one is fail stop assumption. Fail stop assumption is occurred non-volatile storage contents corrupted by system crash. Next one is disk failure. Disk failure means head crash or similar disk failure destroys or all the part of the disk storage. It is used by some OS concepts. Destruction is to detect some failures. Next, see about recovery algorithms. Recovery algorithms already in class already see about transaction. In transaction, how the transaction are work. The start transaction, end transaction, we see all about their topics. Then recovery algorithms, how to recover all the process. The recovery algorithm have 2 parts. First one is action taken due to normal transaction, then action taken after the failure to recover the database contents. There are 2 types of algorithms, recovery algorithms. Next one is storage structure. Storage structure, there are 3 types of storage: volatile, non-volatile, and stable. In volatile, you know that it is called main memory. Main memory is volatile memory. Then non-volatile is secondary storage, that is disk, tab, flash. Then storage stable is survive on all failures, right? Next one is stable storage implementation. Stable storage means what? It is called maintain all multiple copies of each block of separate disk. If the failure occurs due to result is inconsistent copies, that is called successful completion, partial failure, or total failure. Successful means if the transaction fully successfully completed. Then partial means to a destination block has incorrect information. Then total failure means destination block will never updated. Okay. Next one is data access. Data access means physical blocks are those blocks residing on the disk. Next, buffer blocks are the blocks residing temporarily in main memory. These two are initiated by 2 steps: input and output. Input block is main memory, then output is disk. Okay. For example, data access, how to use it. Buffer area, input A is stored in X and B is stored in Y. First read the X element and write, then read the B element and write into Y. Okay. Then recovery and atomicity. To ensure atomicity deposit failures, we first output information describing the modifications to stable storage without modifying the database itself. That means log-based recovery mechanisms, how to work. In this concept, there are 2 copies are maintained: shadow copy and shadow paging. Shadow copy is before updation they are worked. Shadow paging is after update they are worked. Simply these are worked in linked list concept. Next one is log based recovery. Log based recovery, a log is a sequence of log records. The records keep information about update activities to the database. For example, already we see about the transaction concept. In transaction, start transaction and start transaction write into X and end transaction write into Y. Okay. Then database modification. How to modify the database? To allow updates of an uncommitted transaction to be made to be buffer in disk itself before the transaction commits. In deferred modification scheme performs the update buffer disk only at the time of transaction commit. Already see about transaction. A transaction is said to have committed when its commit log record is output to stable storage, right? Then concurrency, undo and redo operations. For example, we working in Microsoft area. In Microsoft simply works undo operations and redo operation, like that here it is works. Then recovery from failure. How to recover the failure files into this? If the transaction time T1 is needs to undo if the log file contains record T1, start, then commit, then start commit. If the failure is occurs, for example, if one process is if the end process is not completed, the one process is abort, means what is the role of the recovering? In that time, redo is original actions of transaction, including the steps to restore old values, that is known as repeating history. Then seems wasteful but simplifies recovery greatly. Next one, checkpoints. Checkpoints, the redoing and undoing all transaction records into the log can be very slow. Streamline recovery procedure by periodically performing checkpoints. Okay. How the checkpoints are worked? During recovery, we need to consider only the most recent transaction. The checkpoint all transactions that started, that is scan backwards from end to log, find the most recent checkpoint record. Okay. How the checkpoints are worked? For example, T1 is starting from the start of the process, then T1 is completed, next T2 process started, then T2 process completed, then T3. Here the checkpoint is here. How to calculate the system failure? Okay. Then recovery system means we covered key concepts. Then basic recovery, then more concurrency, to allow more concurrency. Recovery algorithm, first one is logging. Logging means normal operation, start operation and end operation of the transactions. Then recovery, again we can use two operations, undo and redo operations, is we see about previously. Then example, how the recovery is working. For example, beginning of the record, T1 is start, then some processes occurred, then checkpoint will occurred, next commit, next the second process started, and next one process abort, then third process started. Next one, database buffering. How the database is buffered into blocks. Database maintains an in-memory buffer of data blocks. Okay. Here the recovery algorithm supports no force policy. No force means, force policy means requires updated blocks to be written at commit. Database buffering. In book database buffering is omitted. Next we see about Remote backup systems. Remote backup system provides high availability by allowing transaction processing to continue even if the primary site is destroyed. Then remote backup system detection of failure is how it is worked. Backup site must detect when primary site has failed. Next we see about areas arrays, that is ARIES. ARIES means it is the one of the recovery algorithm. ARIE is the state of the art recovery method. Here we use LSN, that is log sequence number. In log sequence number is used to store pages to identify when updates has already been applied to database page, that is physiological redo, then dirty page table, then fuzzy checkpoints. How the areas optimizations. Physiological redo here used to reduce logging overheads. For example, a record is detected and all other records have to be removed to file hole. Physiological redo can log just a record deletion. Then areas how the data structures are used. There are using several types of data structure. Log sequence number is identify each log record. Then page LSN log records of several different types. Then dirty page table. First one is page log sequence number. To update a page, that is latch a page and write the log record, update the page. Next, to flush page to link, that is removed, erased. Must first latch page, then erase data structure. In the table structure, first one is LSN log sequence number, then transaction ID, then previous log sequence number, redo information, undo information. Here how the transactions LSNs are worked. Next, the dirty page table list of pages in the buffer that have been updated, then contains for each page, then page LSN of the page. For example, if the page 4894 is stored in 7567, the page ID, page LSN and recycle LSN is stored. Thank you.